today's lecture on oscilloscopes, specifically the difference between analog and digital storage oscilloscope that we have to discuss in the today's lecture. Oscilloscope allow us to visualize electrical signals over time, helping us to analyze voltage changes and detect patterns in various automotive components. An oscilloscope is a visual voltmeter with a timer that shows when voltage changes. An analog scope uses a cathode ray CRT similar to a TV screen to display the voltage patterns. The scope screen displays the electrical signals constantly. And the digital oscilloscope commonly uses a LCD, but a CRT may also be used on some digital scopes. It takes samples of the signals that can be stopped or stored. Hence the term digital storage oscilloscope. Analog scopes display all voltage signals and do not take the samples, so they cannot miss an occurrence. A digital scope can miss glitches between the samples, and a DSO with a high sampling rate is always preferred. The digital oscilloscope always depends upon the sampling rate, which is how frequently the device captures the data points. A higher sampling rate is ideal to avoid missing the short events or the glitches. For example, if we are testing a fast switching ignition coil, high sampling rate ensures that you see each spark event captured during the smallest changes. Now here in the diagram, this oscilloscope is used for measuring the throttle position sensor, or we say it as a TP sensor. Now in case of an analog scope, the voltage which is measured at the throttle position, the signal wire is displayed on the horizontal line about 0.5 volts. As the throttle of a TP sensor is open, the horizontal line representing the voltage increases. And in the figure C, you can see when there is a wide open throttle, the horizontal line indicates it is about 4.5 volts, which is provided to the sensor. Now, the another peculiar feature of a digital storage oscilloscope is that it displays the entire waveform from ideal to wide open throttle and then returns to ideal. So we can see the difference between these two figures. In the earlier figures, we were in the analog oscilloscope, we were only getting the instantaneous values. But in case of the digital oscilloscope or the digital storage oscilloscope, as this stores the data, we can get the overall picture on one glimpse in digital storage oscilloscope. And here also the display indicates the maximum reading of 4.72 volts and the minimum of 680 megavolts. The display does not show anything until the throttle is open, because the scope has to set to only start displaying a waveform from a certain voltage that has been reached. So this voltage, we are considering that maximum voltage in this case is considered as a trigger. Coming on to the next important point, that oscilloscope display grid. Most oscilloscope screens are divided into 8 by 10 grids, and they are called as reticule. Voltage is displayed vertically and time horizontally. For instance, if testing a 12-volt battery, the voltage waveform will rise along the vertical axis, while the time axis shows the duration. This grid layout makes it easy to measure and compare values. Now, looking on to this next image, it is a cathode ray oscilloscope. And these are used in analog type of oscilloscopes. Now, in case of digital storage oscilloscopes, we are using a ELCDs. Now, this is the important thing which I want to discuss. That is nothing but setting the time base. The time base on an oscilloscope determines the time per division. For automotive test, the settings always vary. For instance, testing a fuel injector typically requires 2 milliseconds per division, while testing an oxygen sensor may use 1 second per division. Setting an appropriate time base ensures you can observe enough cycles for accurate analysis. Now, take a small example. Here, if I want to see these are the, we can say, other types of sensors. Okay, this already the manufacturers provide us the settings which is required in the oscilloscope for getting the proper reading. For example, in case of this manifold absolute pressure sensor, the time scale on the x-axis is 2 milliseconds per division. For checking a stepper motor, it is a time scale on x-axis is 10 milliseconds per division. For the primary ignition checking, it is 10 milliseconds per division. Secondary also same, 10 milliseconds per division. For checking the voltage, it is around 5 milliseconds per division. And for checking a diode display test, it is 50 milliseconds per division. Now, we have seen what is the time scale on the x-axis, but what about the y-axis? For the y-axis, we have to adjust the voltage per divisions. If I want to check the throttle position sensors, I have to put the y-axis for 1 volts per divisions, and y-axis has 8 grids, so I get total of 8 volts on y-axis. For battery testing, that is charging and discharging, if I want to see its cycles, I have to set the scales of 2 divisions, 2 volts per divisions. Since the battery is of 12 volts, so generally the voltage vary maximum up to 14 volts. So if I set it to 1 volts per division, that is will not be sufficient. I have to set it for 2 volts per division. That will give us maximum of 16 volts on my y-axis. Whereas in case of oxygen sensor can take about max to max 1.6 volts. It is a very sensitive device. So in that case, I can set the y-axis scale for 2 millivolts per divisions. So maximum I get about 1.6 volts on the y-axis. Now, if you see the overall summary of the today's session, we have seen the analog and digital storage oscilloscope. And firstly, we have studied what is meant by oscilloscope. It is how it is different from multimeter. Our multimeter gives us the instantaneous readings, but The oscilloscope gives us the reading with respect to time, and which is very much necessary in checking some of the components in our automotive circuits. That is the sensors in the automotive circuits. Okay, and this oscilloscope is an invaluable tool for visualizing and analyzing the electrical signals in these automotive systems. Understanding how to set the time-based volts per divisions and integrating the display grids helps us in diagnosing the components such as throttle position sensors, fuel injectors, and ignition coils effectively. I hope you have understood this today's lecture. If any student having any doubt regarding today's lecture, please feel free to drop me an email. So thank you.